Hi, thank you all so much for joining me and Fluffy here today to our submission for the Festive Tech Calendar. Fluffy and I have created some great content for you guys, including some of my favorite topics. This includes a Raspberry Pi, Twilio, Azure IoT Hubs, and Azure Data Lake Storage. In the end, we're going to build a data lake for my pet Python Fluffy. You might be thinking to yourself, Lisa, why would we build a data lake for your pet Python in the first place? Let me explain to you. My pet Python Fluffy can live up to 30 years when taken good care of. But taking good care of pet pythons, that means using very specific heat equipment. The humidity and heat needs to be up to par in order for Fluffy to have a good life. But if you think about it, the chance that over the lifespan of Fluffy, which is 30 years, any of my technology breaks, that chance is quite big. And if any of my technology breaks, then Fluffy could get quite sick. This is not something I wanted to happen to Fluffy, so I decided to implement some monitoring using the Raspberry Pi and some sensors. But in the end I found it was just a pity that all of this data just went to waste. What if we could do some things with the data in the future? In order for me to save the data, I decided to build a data lake for my snake. My name is Lisa Hoving and I'm an Azure data engineer. Let me tell you how I built this data lake.
You might be thinking to yourself, Lisa, a data lake for a snake. That sounds very cool and all, but data lakes, isn't that a buzzword? What is that actually? And to be honest, the definition of a data lake can sometimes be a bit fuzzy. So let's look at what some of our biggest cloud providers think a data lake is first. When we go to the Google Cloud website, we find that they think a data lake is a centralized repository designed to store, process, and secure large amounts of semi-structured and unstructured data. It can store data in its native format and process any variety of it, ignoring size limits. Microsoft needed a few more words to explain what they think a data lake is. They think a data lake is a storage repository that holds a large amount of data in its native raw format. Data lake stores are optimized for scaling to terabytes and petabytes of data. Typically, the data comes from multiple heterogeneous sources, and it may be structured, semi-structured, or unstructured of nature. The idea behind a data lake, or so Microsoft thinks, is to store everything in its original, untransformed state. When we go to the AWS website, we find a slightly different definition. They say that a data lake, again, is a centralized repository that allows you to store all your structured and unstructured data. It can be stored at any scale as well. You can store data as is, without having to first structure your data sets. Wow, that was a lot of words. So let's put this in a graph, shall we? Microsoft, Google, and AWS all agree that a data lake must be a central repository in which we can store our data. Microsoft and Google both mention that a data lake holds large amounts of data only. However, AWS tells us that we can store data at any scale, so this also includes small data sets. Microsoft says that within a data lake, we only store data in its raw format. However, Google and AWS don't mention this topic at all. Microsoft and AWS both agree that a data lake can store structured and unstructured data. Google, on the other hand, mentions unstructured data and semi-structured data, so structured data isn't mentioned in the description at all. In the end, all of our technology giants agree that a data lake must be highly scalable, meaning that if we store more data in our data lake just grows. So, if our most favorite cloud providers don't seem to agree, what definition should we use? Let me tell you my opinion. I think that a data lake should be a central repository in which we can store data at any scale. So this means that a data lake shouldn't be able to hold large amounts of data only. It should grow with us along as we store more data in it. So storing a small amount of data, in my opinion, that should be fine. When it comes to storing it in its raw format, what I often see customers do is store data in the raw format and then clean the data along as we go. So in the end, this means that our data lake will hold data in its raw format, but also in a more clean and structured format. So when it comes to storing data in a structured and unstructured format, then this should be totally possible within our data lake. So a data lake should be able to hold structured and unstructured data, in my opinion. Of course, data lakes have to be highly scalable. We should be able to store small amounts of data in there, but also petabytes and petabytes of data if we wanted it to. So even though it pains my heart to say, because of course I'm used to working on the Azure technology stack, I think in this case AWS wins it when it comes to our definition bingo. A data lake is a central repository. It can hold data at any scale. It can store data in its raw format, but also in a more clean format as well. It can store structured, semi-structured, and unstructured data. So the way the data is structured shouldn't really matter. And a data lake, of course, needs to be highly scalable. Our solution is going to have two components. First of all, I want a Raspberry Pi to read the temperature and humidity of my terrarium. If one of these terrarium readings are off, I want to get a phone call. Unfortunately, at the moment of making this video, I am unable to get a phone call using Azure because only the US phone numbers are allowed to get a call from. So I need to find a solution somewhere else. At this moment, I'm using Twilio to call myself when one of the terrarium readings are off. Next, we want to send all of this data to Azure. So to do this, I'm going to use IoT Hubs. Using a Raspberry Pi and some Python code, I can send this data to my IoT Hub. Using a sink, I can sync this data directly into my data lake storage. Azure Data Lake Storage is actually a perfect way to start building a data lake because, first of all, it's a centralized repository. It can hold data at any scale, and we can store data in its raw format, which is what we're going to do with our JSON data coming from the IoT Hub. But if we want to clean and transform that data, we can store it there as well. Azure Data Lake Storage can hold data in both a structured and unstructured formats. Basically, the JSON data that we're going to store there, some people call semi-structured and some people call unstructured data. But if we want to further structure our data sets, there's nothing limiting us when we use Azure Data Lake Storage. I could store it in another format, for example, Delta Lake as well if I wanted to. Azure Data Lake Storage is highly scalable, so we can store data of any size in our data lake. Please do keep in mind that normally for a data lake solution, we would have a tool like Databricks or Azure Synapse Analytics to clean, transform, and analyze our data sets. This is not going to be our focus today, but do keep this in mind when listening to this video. Before we can go ahead and use our data lake solution, we of course have to deploy some infrastructure on Azure first. So let me show you how I did it. Okay, so first we're going to deploy the Azure IoT Hub and the storage account that we're both going to use to create our data lake. So let's go ahead and create the IoT Hub first. I'm going to go ahead and click Create. Putting this in the resource group that I've just created for demo purposes, and I'm going to call this IoT Hub Demo Fluffy. Then, since we are in the Europe region, I'm going to look for West Europe, which is always a bit of a struggle for me, unfortunately. Where is it? Oh, there it is. Okay, good. Then I'm going to do something that is not recommended, which is accept the defaults. And here it's important, I'm going to make a free tier of Azure IoT Hub, and this ensures that our IoT Hub solution is going to be free always when it comes to the IoT Hub, but of course we pay a little bit for the storage. Okay, just going to go ahead and create. Good stuff. Okay, we're not going to wait because we also have to create the storage account. This I'm going to do now. And I want to create data lake storage, so it's important that we enable the hierarchical namespace later on. But let's go and put it in the right resource group first, and then I call this IoT Hub demo fluffy storage account. I'm going to struggle a bit and look for a West Europe already. Okay, good. And I don't need any replication because, well, if the data get lost, that's unfortunate, but not the worst for a demo. So I'm going to enable that hierarchical namespace that ensures that I can create a data lake. Going to accept all of the defaults for demo purposes. Okay, and now it's going to review and I'm going to create this resource. And then we wait a bit and we have our infrastructure ready. Okay, so we're back and Azure has deployed all of the infrastructure that we need. But now we have to tweak them a bit to ensure that we can use them for our data lake purposes. So first of all, I'm going to need a container in my storage account to ensure that we actually have a place where the data can land. So I'm going to call this sensor readings. And I'm going to go ahead and create this. So this ensures that we have a place where later on our JSON data, which is the data coming from the IoT Hub, has a place to land, first of all. Okay. And then second of all, we need to ensure that our Raspberry Pi has something to connect to send the data to. And this we do using devices. So I'm going to go ahead and create a device in my IoT Hub. Okay, so I'm going to call this Pi. And I'm going to save. Okay. So this is probably going to take a bit of time. And that's okay. And we can go back later on and see if this deployed. Okay, so we have waited a bit and now you can see that the device has indeed appeared on the screen. Sometimes that happens, you just need to wait a little bit and then everything resolves itself. As you can see here, I've created a device with the device ID of the Pi. So this is what the Raspberry Pi is going to use to connect to the IoT Hub that is. We have a primary key and a secondary key that we're going to utilize to connect and the device is enabled. Of course, when we send data to the IoT Hub, we want them ultimately to land in our storage account. And in order to ensure this, I'm going to configure some message routing. So let's do that next. Going to add a route. I'm going to call this Slytherin to Azure Data Lake Storage. I think that is applicable. And we want to slither this to our storage account that we just created. So I'm going to call this the Snake Lake. And I am going to pick a container here from my storage account. Select. And it is going to be JSON. And here we can fill in the file format that we want it to go to. I'm going to accept the defaults, which means that in this case, we will get a folder for the year, the month, the day, the hour, and the minute that this message came in. But we could, for example, also make a decision to make this one folder and then to just have it per JSON. But for now, I think this is fine. So let's just go ahead and create this. Okay, so we give it a second to load and now you can see that my endpoint, the Snake Lake, has configured itself. Our data source is going to be the device telemetry messages. This means that the messages that the Raspberry Pi is sending to the IoT Hub, these are the messages that we are going to go ahead and send to our data lake storage. I'm going to enable the routes when I click save, so to ensure that this works from the get-go. And I'm not going to test my query because, as always, I'm overly confident that my solution will immediately work. Okay, so let's give this a second and then I'll get back to you shortly. What did we do? As you can see here, we've deployed an IoT Hub and a storage account to go with it. But what are we going to use it for exactly? So this IoT hub that we have deployed is going to hold a device which is called Pi, and this Pi is the device that our Raspberry Pi is going to use to connect to our IoT hub. Here you can see the device name is Pi, and if we click on this, we can find all of the primary and secondary keys that we need to connect our Raspberry Pi to our IoT hub. Of course, when we send our telemetry data to the IoT hub, we need them to land somewhere. We don't want them to stay in the IoT hub. So we have created a message routing. In this case, I called it Slytherin to ADLS, Azure Data Lake Storage, and the device telemetry messages. So these are the messages that our Raspberry Pi sends to our IoT hub. These messages we are going to sync to our data lake storage. In the data lake storage, we had created a container to ensure that our data can land somewhere. This we called sensor readings. Now we have our Azure infrastructure ready, we can start thinking about the next steps. The Raspberry Pi I'm going to use today is a Raspberry Pi Model 4B. I've installed Raspberry Pi OS Lite on it, 64 bits, and this version has been released on September the 22nd of this year, which is 2022. In order to get some humidity and temperature readings, I'm going to use an Adafruit DHT22 sensor. In order to hook this up to our Raspberry Pi, I need some jumper wires, so these I've bought as well. In order to ensure that this temperature and humidity sensor gets some power, I also need a resistor. And lastly, to connect everything together, I have also brought a breadboard. So let me show you what it looks like. This is the setup we're going to use today. As you can see, I have a Raspberry Pi 4 Model B. And hooked up to the Raspberry Pi, we have an Adafruit DH22 temperature and humidity sensor. Well, this temperature and humidity sensor, we need to hook up to the Raspberry Pi using the 3 lines. So the black line is the ground, and the yellow line is for the data pin. I have actually connected it to the 17th data pin, GP17. And then we need 3 volts power connected, which is the red line, and the red, which is the power, and the yellow line, which is the data, we connect using a resistor to ensure that the temperature and humidity sensor doesn't get too much voltage. So make sure to hook this up right, or weird things might happen. Before we continue, there's one thing I want to point out to you. And this was also something that really confused me when I started off using the Raspberry Pi. If you look at the GPIO board, what we can actually see here is that some of the pins are duplicates. So this means that we have multiple ground pins and multiple 3 voltage pins. When it comes to these pins, it doesn't really matter which one we hook up. But when it comes to the data pin, we need to ensure that we tell Python, the Python code, what pin we've used. So in essence, we could use most of these data pins, but we need to tell the code what pin we used in order for our Python application to understand where to get the data from. Before we can go ahead and start coding, there are a few bits and pieces that we need to get first. So let me show you where to get these. I'm going to assume that you've already created your own phone number using Twilio, but if you have not, that is totally fine. I will put a link in the description box below so that you can go ahead and create your own phone number as well. I've already logged into my account, and if you scroll down a bit here, you can find your account info. Here we need to copy the account ID, the authentication token, and the Twilio phone number that you've just created. So I'm going to copy all of these things. And these we are going to use later on in our Python code to connect to our Twilio account and make a phone call. Next, of course, we also want to send this data to the IoT Hub. So for this, we're going to use the device that we've just created together. So here we can see the Pi device that I've just created. And here we can find the primary key, the secondary key, and the connection strings. So I'm going to use the primary connection string to connect to our IoT Hub solution. Alright, and that's it. All the bits and pieces we need in order to get coding. One thing that always really grinds my gears when I'm following along with the tutorial is that I'm starting off with a fresh version of my Raspberry Pi, and the tutorial doesn't tell me all of the dependencies that I actually need from the get-go in order to get the solution done. So if you're following along today, make sure to pause the video and install all of the dependencies that are mentioned here. So these are all of the generic dependencies that you're going to need in order to run the code. Next, the Adafruit sensor has some specific dependencies as well. So again, if you want to follow along, make sure to install these dependencies and follow these steps. As you've guessed it, Twilio as well needs some dependencies, so make sure to pip install Twilio. Lastly, if we want to connect to our IoT Hub, we need to pip install the Azure IoT device. And there we have it, all of the dependencies that we need in order to start coding. Let's start with the first component of our code. In this case, this is going to be getting the temperature and humidity readings from our sensor. What does that look like? What we see here is I start the Python shell first. Then I need to install the packages, in this case the Adafruit. Then I want to get some readings from them, and I need to find the correct pin, which in this case is the 17th pin, as I've showed you. Now I got the humidity and temperature readings. I can round them to ensure that I get the format that I actually like. And here you can see that the humidity is, at this moment, 57%. Now I want to get the temperature as well, so let's print that to our shell. And here we can see that the temperature in my living room at this moment was about 20 degrees. The second component that we're going to use in our code is Twilio. I wanted to get a phone call, right, when the temperature or humidity readings were off. So first I'm going to import the Twilio client, and then I'm going to copy and paste in my window the account ID and the token that I just got from their website. Then I will fill in the phone number that I want to call from and the phone number that I want to call to. With the account ID and the authentication token, I can go ahead and create the client. And then lastly, I'm going to put in some fictitious humidity and temperature readings. So these can be used in the call to Twilio, and this we can later make generic in our code. Lastly, let's copy the client call and kick it off. Let's see what happens.
There is something wrong with the terrarium. The humidity is 60 and the ambient temperature is 40. Please act now.
The next component of our code is going to be to send the data to our IoT Hub. So I'm going to go ahead and start the Python shell, and then I'm going to install all of the dependencies that I need. In this case, the Azure IoT device. More specifically, I need the IoT Hub device client, and of course I want to send a message, so I need that as well. Next, I'm going to copy-paste the connection string that I just showed in the portal, and then I'm going to go ahead and create the IoT Hub client. Of course, I want to have a message that I want to send to our IoT Hub, so I'm going to go ahead and make that in a text format. But actually, as you can see in the structure, it's a JSON. I'm going to format my message. And then lastly, I need to tell my application that actually the message I'm sending is of format JSON. So it's going to be application/JSON, and it's in an UTF-8 format. Now I'm done, I can go ahead and send my message to the IoT Hub. Let's put all of our code together. Of course, we don't want to store any secrets within our code, so I'm going to parse some arguments to ensure that we don't need to do so. In the end, I want my application to monitor continuously, so I'm going to implement a loop. What's in the loop? First of all, we need to read that sensor that we had for the temperature and the humidity. I want to check these to ensure that everything is up to par, but if this is not the case, I want to get a call using Twilio. In the end, we want to save our data within the data lake, so we need to send that to IoT Hub. So where do we start? Of course, we need to read that temperature and humidity sensor, right? This code that we use is basically what I just showed you, and we're going to return this to use for other functions later on. The temperature and humidity are things I want to check, and if these are not up to par, then I'm going to use Twilio to give me a call. So if the ambient temperature is above 40 degrees or below 20, I want Twilio to call me. And you guessed it, if the humidity is above 80 or below 55, I want to get a call as well. The call function is pretty similar as what I've just showed you, except for the fact that we use the temperature and humidity readings that we just created. If these are not up to par, we will make sure that we get a call. In the end, we wanted to send our data to the IoT Hub, so we need to initiate an IoT client first. Using that IoT Hub client, we can send the data to our IoT Hub. We do have to ensure that the content encoding is set to UTF-8 and the content type is application/JSON. So this will ensure that our message routing understands that JSON correctly and can pass this through to our data lake storage. All right, so let's give that a try, shall we? I went ahead and put all of the code in the Raspberry Pi under the telemetry.py file. This we can use to call our application. As you can see, not all of the temperature sensor readings are correct, so I'm getting a call. And there you have it, everything together on the Raspberry Pi. Let's check back with our storage account. Here we had created a container called sensor readings. In this sensor readings container, we now, as you can see, have a folder called IoT Hub Demo Fluffy. This year is 2022, in December the 3rd. On this time, we can see that we wrote a JSON file, which is the call that we just executed on our Raspberry Pi. Cool. And there you have it. We've just built a data lake for my snake using Azure IoT Hubs, Azure Data Lake Storage, a Raspberry Pi, an Adafruit sensor, and some Python code. You might be thinking to yourself, Lisa, what are we going to do with all of this data? Well, to be honest, in the realm of data, the opportunities are literally endless. So that topic we are going to save for another day. In the meantime, if you want to play around with the code I used, I'll make sure to make it available to you in the description box below. Hope to see you again soon.